Velocities in two dimensions become vectors. Each vector has a magnitude and direction. Vectors don't have a set position, so they can connect with each other, creating a resultant vector that is the sum of the added vectors. It's like if you push a box in one direction with one force and then push it in another direction with another force, it is the same as if you push it to that final point in one go. A vector can be split into its vertical and horizontal components, which is found using trig, and the magnitude can be found using the components via the Pythagorean theorem, and the direction using tangent. To add vectors, you take the horizontal and vertical components that make up each vector and add them respectively. Vectors would be a tangent line to a projectile's motion, since that's the direction the projectile is going at that given point in time. One thing to point out is that the horizontal and vertical components are independent of each other. An object that moves vertically and horizontally would have a greater net force to it compared to an only vertical force, but it would travel the same distance vertically if the vertical force added on both objects is the same. Gravity only affects y, not x. The same kinematic equations are used, but you use x or y depending on whether it's horizontal or vertical. There is no acceleration for x because air resistance isn't considered at this point, so the chunky kinematic equation shortens down to x equals v naught x times t. This means that an object would move horizontally at a constant velocity. Its vertical velocity would decrease due to acceleration, and at its peak, the vertical velocity is 0 and only the velocity of the object at that point is horizontal. The kinematic equation for y is also the chunky one, but it's not as clear-cut as the x. You might have to use the full equation if you're given an initial velocity that's not 0 for y, but when you're dealing with a scenario where you're calculating the object at its peak, that is when the y velocity is 0, so you can just use the 1/2 gt squared part of the equation. Another equation is the range equation, which finds the total x distance traveled and is found by manipulating the x and y kinematic equations. This proves that a max range is reached with an angle of 45 degrees, and that there are two different angles that can reach the same range. When you label an object's velocity relative to something else, you have two subscripts. The first is the object, and the second is the reference frame. With wind and water currents, the ship or plane might have to steer against the current to go straight, so relative to the element, it's going in a slanted direction, but looking at it from an outsider's perspective, the ship or plane is actually going straight. Note that the inner subscripts match, while the outer subscripts match the subscripts of the resultant vector.